Hello, hello, hello. Advent of code. Day 4. I'm ready to go. I'm not sure things are ready to go. Yes, they are. Okay, got my code ready. Problem ready. We're gonna find out what we're gonna be doing in 10 whole seconds. Let's do this. We got ourselves a nice looking grid. I'm seeing the word Xmas in here, so I might be doing some pathfinding or word searching. How many times does Xmas appear? Here is the same word in the search again, but where a letter is not involved or replaced with dots. Is this just searching for the word Xmas? Okay, that seems straightforward. Unfortunately, something got my eye before I started. Const world equals data split map line, convert that line into an array. Okay, are they vertical? I do see verticality. Okay, so we need to look in all directions. Let's do this. So for let r equals 0, r less than world.length, r plus plus. So we're going to search every position in every direction. Now let's define our directions. So we have our direction of, well, let's just make a bunch of zeros first. Fortunately, it is just the cardinals. I don't believe we're looking diagonally. You need to find all of them. Do we see a diagonal? I do see a diagonal here. That's our exact thing. In the word search 18. XMAS. This does appear to support diagonals. Okay, so it's not going to be that simple. Well, it's just going to include more cases. So those four, all of the directions, which I could just build with a loop, but I'm already writing this. So 1, 1, 1, 0, 0, -1. Sorry, my mind does not like this. -1, -1, 0, -1, -1. Yeah, you know what? I'll just do the actual loop for this. So for every position, if world RC C not equal beginning of our word, which is the letter X, then continue. We can just skip on life. Now we can loop through our offsets. R equals -1, RO less than or equal to 1, RO plus plus. CO. Same thing for column offset. Go if RO equals 0 and CO equals 0. This means you just said go nowhere, then we'll ignore this one. Otherwise, we'll have a new R and a new C. RO plus R plus row offset, column plus column offset, and can't use those words, so new row and new column. And then we need to, I guess we kind of need to build this and detect each character's in each position, which I'm not doing. well, no, we need to generate it, and then we need to go forward in that direction three number of times. So for cost car, well, call it ci and car of um 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 Xmas. What the part two of this is gonna be? If world, I guess we kind of need to do this down here, unfortunately. R plus RO times CI give this multiplicative effect. If, oh, come on, cursor, get back down there. So if this, protect us from going off the end of the world, not equal car, continue. So this will basically be up here, left bound, false, bound equals false. So we'll assume it's true and flip it to false when we fail to find it. So it'll be more of a break when we fail to find it. If found Xmas's equals 0, we'll add 1 to Xmas's. I think this is it. It's a little brute forcey, but there we go. I'm trying to figure out what this one is. 1, 2, 3, 4. Okay, so it was 4 for there. Let's add another example, which is here. $18, which is what it says. Nice. Okay, we need our real input now. See if it eats my computer alive. That's a number. Okay, part 2. Xmas puzzle. 2 MAS in the shape of an X. The only way to achieve is like this. Relevant characters have been dots. Each MAS can be written forwards or backwards. Okay, honestly, that's not too bad. I just need to find all the MASs. Okay, this is easy. I got this. Let's write this. What am I returning for this? Am I returning how many times does it appear? Okay, so it appears 1 in this tiny one. And then in that one, apparently 9. Got this. Okay, let's do it. Okay, so right now we're just detecting the word Xmas. We are actually looking for MAS, and we need to detect if the middle coordinate is the same for any two, and if they are, we're good. And we are doing any directionality, so I think we just detect if the MAS is 2 for any of them. So it's a great reason it's a great thing I did this somewhat modular. I can drop the X, change this to an M, and change this to MMSs. And instead of adding, I will create a dictionary of mappings of how many times I've seen it at its middle coordinate. So it will be masses. Then let middle chord equals null. Possibly if ci is 1. If ci is 1, middle chord equals NR and C. There we go. And then if found middle chord dot join with this bit, if found and middle chord, don't you worry about it, equals well, it's going to be equaling it plus 1. So we might actually see it 4 times because of multiple detections, but we'll see about that. Okay, we'll see it twice. Okay, we search for it in one direction. We don't do backward searching. Okay, this is great. So we just need to find all the values which are returning to, and that's our count. Return object values, masses that filter, count equals 2, and yeah, this is a better way of doing this, but we've done it this way. 7 does not equal to 9, but why not? Okay, so I see it's how many there are. So there's 1 here. 1, 2, 3, 4, 5, 6. What are we looking at in this mumble stuff? 7, 8, 9. No. Okay, I kind of need to do some highlighting on this to this point. Okay, let me look at what we have for you, Mr. Problematic. We can get some of 3, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey! Okay, so I guess we're doing greater than or equal to 2. Will that make you happy? That's a number. A little concerned about the number because it's not following my logic. Yeah, felt right. Okay, so I need to just look at these and do some highlighting or something. Yeah, I could just take the world and set the middle coordinates to something else. Let's go for that. So for const en masses, const rc equal key splits on the vertical, mapped back to a number, world r, c equals, I'll put a 0 here. So that'll be easier to look at, and then we'll look at the world. So that'll be put them back into a string and join these back up like that. But stop looking at the big one. That makes my eyes hurt. Okay, you're not really console logging at that point. Hey, let's. That's not really helping. Come on, give it. You're really not helping. This is the least helpful map I've seen. What the heck is... Why are you not looking good? Ah, well, weird. Okay, I'll just manually go in there. Why? Oh. What? Oh, I've stopped console logging it. There we go. Now I can actually read it. Let's do some spacing. So we have it here. 1, 2, 3, 4, 5, 6, 7, 8, 9. What the? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, counting is good. You follow this again, in which you're supposed to find two MAS in the shape of an X. It's like this: a relevant character of dots. Each MAS can be written forward or backwards. I'm not looking for them backwards, but I'm searching every place for every direction forwards in all directions. So that should have made it work. And the MASs, yeah, it would work. Oh, no MAS. Okay, let me write a test case for verticality, normal stuff like that. Dot S dot MAS M dot M dot. Yeah, there's one there. Okay, that's working, unfortunately, how I expect it to. How many times does an X miss appear? What does my input look like? Doesn't look that bad. I need to do some trimming on it. Let me see. Data equals data. Trim. Sometimes that helps. 2559. Let's put that back on. 2559. Interesting. No spaces in here. Okay, so we're just not seeing it. Why are we not seeing it? It's one of those instances where I feel like I am looking right at it. Okay, let me. So the fact that I'm seeing threes here is my clue that it's not following exactly my mental model. So let me investigate that. So 2, 6, and 2, 7 are threes. So 0, 1, 2, 6, and 7. I'm seeing this 3 times. So MAS, MAS, nope, MAS. Uh-huh, there are 3 crossing into 1. Okay, that's the case. It's really it's not from the way of looking at it, but we have a MAS, which should be 2. And then if we had another one, don't fight me now, formatting, which is up here, we should have a 3. Is that my correct? And this one is supposed to be 9, though. In the shape of an X, not the shape of a T. Dang it. So it's not supposed to be that. It's supposed to be 1 and 1. I'm detecting a bunch of T-shaped MASs because I'm doing this thing which gives me horizontal checks. So if RO equals 0 or CO equals 0, continue. Stop looking horizontally. Yeah, which means this test case is literally illegal. Yeah, we do not look horizontally. If anything, this one gives me 0. And this one gives me 0. Okay, let's see about this. It's a smaller number, which is what I would expect. Boom. Okay, we got it. Directions. You should read them. But yeah, that was a pretty good one. Gonna go ahead and take my break. When we come back, we will walk through the challenge, my code, refactor it, and walk through that refactored version. So, see y'all on the other side. Returned we have. So, we did it. What did we exactly do? So this is kind of just like a search for the word problem. Our first one, we were given a grid of characters. We were told to search for the word Xmas. We were told to do it horizontally, so left to right, right to left, top to bottom, bottom to top, and top left to bottom right, and top right to bottom left. So all of the possible directions. Then return how many times Xmas appeared. And that's it. That's all we were told to do. So if I were to grab this, go in TL draw, turn it white, and just play effectively, find the Xmas. What I would do is I would, as a human, do some quick pattern recognition and be like, aha, there's one. And make that small. And then I'd be like, oh look, there's another one. And then oh look, it's another one. And then another one. So I would have found 1, 2, 3, 4, which is how many is in that one, though they don't tell us. Where's that one? Which is that one? Then they give us the bigger, harder one, which will be an actual challenge if we were doing this for real, because look at all them other words that aren't Xmas. You see, what I'm doing is I look at an X and I'm like, okay, can I find an MAS from this? Not really. I'm not good at this. Here's another X. Can I find an MAS from this? I can find an XM. Nope. Here's another one. XMAS. Whew, I found one. And that's supposed to be green. So yeah, it's that process, but we want the machine to do it for us, because you can just see how long it took me to find one, and we want to do it in a more deterministic way. But whenever you do those, you find all of them, and you get the number of how many there were. It's relatively straightforward. Part 2, however, is looking and seeing, okay, you weren't supposed to do that. There was a hyphen left out in the instructions. Very funny. Oh, wait, is there something else? The joke was too dumb to pass up. Oh, that's great. So instead, you're supposed to be looking for the words MAS that make the shape of an X. So if I were to bring this one, we're looking for the occurrences that make up a literal X. So we find MAS here, which is great. It means absolutely nothing to us. Then we find a second MAS down here, and boom, this makes an X. And then we keep looking, we find MAS here, MAS here, boom, makes an X. MAS, we also find one here going horizontal, but that means nothing, because you're not supposed to be looking horizontal in part 2. You're supposed to be looking just the diagonals, and just for MAS. So that one, you can actually look at that one. And then you're going to see another one. Like if you were naive and looking vertically, you'd see this. So you'd actually see 2 MASs, one making a T shape or a plus sign, and one making an X. But the instructions say we're only looking for X's, not pluses. So we ignore those. And then we find 2 more MASs. So right here and right here. Boop. So there are 2 here, one beside each other. And another one right here. Another one right here. Another one here. Another one there. And all my drawings aren't the best. Find these 2, these 2, these 2, those 2 there. So if we were to count up my well-drawn blobs, we get 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 of them. That's how many MAS crossings we have, or how many Xmas's we have. Again, not the best drawing, but gets the point across, and that is what our challenge is asking us to do. Looking for MAS's in the shape of an X, not a plus. I think that's about it for the what. Now for the how. Well, the way is how is you get your friend Steve and you give him this, or you get your favorite child who loves crosswords and be like, hey, look, I got a cool problem for you. Or you write a computer program to do it for you, which is what we ended up doing. So, the way we approached this, so I approached this initially. Let me clean up some bits for a commit, actually. Yeah, those aren't useful. There we go. Let me commit these. Where'd it go? Where'd my thing go? Here it is. Okay, now back to the walkthrough of the solution. We'll go through the first one. So, we first convert our world into, or our data, into an array of arrays. So we convert it into a nice little matrix. So now world, it looks like this. This is actually a perfect visualization today. 5 arrays of 6 each. We do this mainly just to prepare for any manipulations we need. Turns out we didn't actually need to do this. We could have just left it like this. Works just the same. Because strings are indexable just like arrays are. But then we iterate through every row and every column from top left to bottom right. So let me look at an example. Row 0, column 0. So if I were to break this out back over here, turn that back to white. Let me put these here. Are more spacing actually. So these are the rows. 0, 1, 2, 3, 4. I can't count. My apologies. And then we have 0, 1, 2, 3, 4. Yep, so these are our rows. These are our columns. I can't put spaces anywhere. There we go. So when we say 0, 0, we mean this position here. And eventually this will continue on. It'll go on to the next column. So eventually it will go to... Ignore that. It'll go to 0, 4, which is this coordinate here. All that to say, we search through it, and if the current character is not an X, so remember we start at row 0 and go through all the columns, so this is not an X. This is not an X. This is an X. Congratulations. So we're going to do the thing. And that thing, in this case, involves calculating a row and column offset from -1 to +1, which is a way to effectively calculate what I was about to hard code up here, an array of offset directions. So the first one we do for this is -1, in which we try to look for the characters XMAS. So we try -1, -1, which puts us going in this direction. So if I draw a really cool arrow, I'll make it yellow. Puts us going, no, don't do that. Let me get in here. Going in this direction. Unfortunately, there's nothing in that direction. Like, it's the void. There's no universe there. So when we go in that direction, we generate our index of our character, and our character, we start with 0 because I wrote the code inefficiently. Eventually we get to the 1th character, which is the M. So we look out here. We go to the coordinate, which would be our -1, column 1, because 0 minus 1, and then 2 minus 1 puts us over here. And we find nothing to the point where we access that row and it's undefined, so we don't want to explode like this, so we use the optional chaining to make sure we evaluate to undefined. It's not the character. We haven't found it. We give up. So then, well, we haven't found it, so we go to the next iteration, which is column 0, which is basically saying don't change the column, just change the row. So we look there. Again, we don't find anything. We look here. We don't find anything. Now, we're on the next row offset iteration. We look here. We do find something, but it's not the letter M. So we give up. We then look at ourselves. Except we don't look at ourselves. If both are 0, we don't look at it. Then we look to the next one. We don't find the letter M, so we give up. We go to the next row, the -1th column offset. We don't find the M here. We don't find the M here. But then we go here and we find the M. So this statement does not run because it is equal to character, which means, well, we go to the next iteration of this loop, putting us on the A with a CI of 2. So our current position plus our offset times 2 in both directions. So this was it times 1. This is it times 2. Do we find the letter A here? We do. So we do not say found false and break. So we keep going. Times 3 for the S. We find the correct character. So this doesn't run. We don't set it to false and we don't break. Although that's the end of our loop here. We don't loop anymore. So we exit the loop and we check, hey, did we find what we were looking for? In this case, we did. We never didn't find what we were looking for, which means we found what we were looking for, and we increased the count of Xmas's. That is exactly how this algorithm works. It's not the cleanest, especially with this calculation being inlined, and with this kind of just being here arbitrarily. Because for the price of can technically handle any letter, it's a little harder to follow because it's a loop instead of just 3 manual MAS lookups. But that's how the solution works. Yeah. For part 2, everything is the same. Okay, everything's not the same. Our first change is that we're keeping track of all the MAS that we've ever seen. And when we are going through that iteration of, hey, let's look at literally everything around us, if we look in a horizontal direction, which is having our row or column offset to 0, we don't look at it, which means we look in this direction, this direction, this direction, and this direction only. We don't look in the horizontals no more, because that would allow us to find as a plus. We're not looking for pluses, we're looking for X's on the map. So that's what this check here is for. Next, we keep track if we have found the middle coordinate. This is important because we use that middle coordinate to determine if like basically it's the middle of the MAS. So if two middles ever cross, then we can say we've been there twice. Let me go and do this on the real map. So, I'll do the same as I did before. So, R0, 1, 2, 3, 4, 6, 7, 8, and 9. So those are all of our lovely rows. New line, column. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This has been counting. Thanks for joining me. So we are looking, let's look at this first one, MAS. So we already did effectively the searching for it. So as we go through here, MAS, boom, we found it. And as part of it, get rid of this, make it a little easier to follow. Boom. So we go through it, and according to this code, once we hit an index of 1, we keep track of the middle coordinate, which is basically, in this case, MC equals, so the middle coordinate, it's 2, 2. Hey, Rask, hello, hello, how's it going? Hello to you too, Mendoza 2001. So yeah, we find this middle coordinate and we keep track of it. If we do find what we're looking for here, then we actually record that. Yeah, I don't think mine's too performant either. It's very brute forcey search for all the things. But no concerns with timing here. Yeah. My main thing was for I'll not say it. I'll say it in spoiler less terms. I was looking for pluses when and X's when I should have just been looking for X's. But I figured it out. Yep. I'm also had a little wasn't as bright-eyed and bushy-tailed for this one myself. So when we check that middle coordinate, we look for where the middle coordinate we've seen, and we add 1 to it or set it to 0. So it starts off nothing, and then we like, hey, look, we found something. It's 2 colon 2. It's this. And that's what we do when we find that first MAS. And then eventually we make our way and we will find another one. And its middle coordinate is also 2, 2. So it goes to update the MASs, and it finds there's already a value here, so it sets it to 2. Ah, that sucks, Rask. Yeah, you think TypeScript would help you? Yeah, I might put some of these in the comments, some of these drawings in the comments to help. Hmm, hadn't really thought of it, but yeah, it does help. That's kind of why I do the solution and challenge walkthroughs to walk through the challenge and solution. But I do attach these to the solutions, so I attach these videos to the solution. So there is some traceability back. They're just not exactly in the code, but I can try that for sure. Yeah, compared to part one, that is the main change of what I do to track the MAS crossings. I generate the middle coordinate. When I find a valid MAS, I put it in the I've seen you before, and how many times I've seen you before? Tracker, which is this MAS's dictionary or hash map. And then finally, I'm like, hey, how many of these have been crossed at least twice? Which I think I can go straight for equals to. No, I can't. Well, not if that many equal signs. Yeah, turns out I didn't need the greater than or equal to. Well, do I? Yeah, the equality works just fine. But yeah, that is how my solution does the thing. Yeah, Rask, I thought about doing some kind of utility-based system where I don't have to keep rewriting all of these every time or rewrite direction offsets, coordinate changes, but eh, it's not that bad. Yeah, always having in north, south, west, east, cardinal directions, diagonals. Yeah, I've seen some other people go that degree and have utilities for converting strings into matrices, dot lines, all kinds of cool stuff like that. Maybe one day I will. I'll get tired of writing this. Mm-hmm. Yep, they are one of them. Okay, it's a refactoring time. So what do I want to do refactoring wise? It's obviously there be some overlap. So it's what I'm looking and if I'm looking for a crossing of them. Oh, definitely, Rask. Yeah, this is far from the first coordinate based challenge. Hmm. Okay, so I think what I want to do is I want to generalize the entire thing. So I want to generalize the entire thing to track to first allow me to provide a substring to search for, and then if that one happens to be even or odd length, turn me the middle coordinate of its happening. The concern of that is that in this version I'm ignoring pluses, so I need to do something in my generalized to also ignore that. That's a little cleaner than wacky boolean that changes into functionality. Mm, I'll go with wacky boolean first. Okay, so function find words data string. Let's do this. I guess we're going to see what word we're looking for. So not equal word 0. You failed. And then, yep, we'll spread the word here. And then it'll be, we're not really doing a find, we're just doing a count, honestly. And yeah, we will continue iterating on this very shortly. So this one is basically return count words data xmis. Boom, well, we did it. Let me add an additional assertion for our real data though. I always keep forgetting to do this. 24, 8 something. 2483. Boom. Love it. Love it. I'll go do that for part 2 down there. 1925. Beautiful. Okay, now we have those test cases made in actual test cases. Let me continue with this. So I've generalized it, but then I've re-narrowed it down to giving me a count. So let's regeneralize it again. I just want to find. I think I want to return the word and not the word, because we know what the word is. It's Xmas. We don't need to return Xmas. I want to return the coordinate position it was found in and the direction it was found in going. That will be enough information for me to do the other stuff. So find words, cost found. I'm going to type this here right now. So found. And so let me figure out what I want this to be. I want this to be an array of things. That's great. I guess I'll have a row number, column number, direction, and then I'll have a row number, column number. And not the cleanest. These are basically vectors. Don't tell nobody. Okay, if we find it, let's push to found. I just used the word found twice. Whoops. So found words. There we go. It's a little better. Found words. Push. Row is. I don't want to say. I mean, it's row and column, right? And then direction is row C O. That is correct. Then we return. We found words. And for the purpose of counting, well, we're just gonna do a dot length here, aren't we? Find words. A dot length. So yeah, solve the one, still perfectly happy. I think we add that crazy boolean. It wouldn't even be a boolean. So this is where we're going to go double optimization. Instead of providing a boolean, having this modify what directions we take, we're going to go back to the hard-coded directions, right? So let's build all of these out. I like generally doing this because it can be somewhat easier to follow. And as you can see, I was missing one. Oh no. Let me add space my -1. Okay, so 1, 1, that's wrong. -1, -1. No, put it back. -1, 0, 1, 0. And yeah, this is where, as Rask was mentioning, utilities gonna make this a lot easier. Row doesn't change, column does. Don't look at the middle. Row doesn't change, column does in the positive. Row goes -1. No, row goes 1, column goes -1. Row is 1, column is 0. Row is 1, column is 1. Boom! Those are the all directions in this lovely array here, and we love it. Let me break this into two. Cardinal directions, and I'm just gonna break this down. -1, 0, 0, -1, 0, 1, and then 1, 0. It's weird ordering, but it's good. And then const diagonal directions, which is the other ones. -1, -1. Let's go to an array. 1, 0. That's not right. It's 1, 1. There we go. This is why this matrix helps a little bit. I mean, didn't help till the very end there, but whatever. 1, -1, and then 1, 1. So we have all of our directions, diagonal. Apologies. I know how to spell the word diagonal. Boom. Yes, we have our cardinal, we have our directions, and I might as well call this all directions, and instead of defining it, we can squish the above together. Just like that. Now, why did we do that? Well, we did that so we can do this down here, our CO of all directions, and allows us to not have to calculate this here, and allows us to reduce a level of indentation, which is great, and allows us to reduce that line there because we don't have the coordinate that looks, we don't have the direction that just looks at ourselves. So that's great, that's lovely, it's cleaner. Who cares? Well, it's broken. So this is why we have test. So we can now, when we mess things up. Apparently I messed it up. So I got 5 and there's supposed to be 4. So if anything, I would have expected to get less, not more, but okay. Interesting. Well, the great thing is that we can just use our eyes and look. Well, not our eyes, really, but... There we go. Look at all these rows and columns and rows and columns, and we just want to look at the first one, please. Still a lot of rows and columns, but a lot that we can use our eyes and just capture here. Now I know the ordering that I'm doing and the way that the ordering that I was doing before aren't the same, but that should not be the end of the world. So let's try it again. ROCO of all direction. No, not the word all. All directions. I drop these two. I drop. Let's see what I'm getting here. I'm getting a bunch of other coordinates. Now we'll just take them and we'll use our eyes to see what we see is wrong. So let's check for -1. Yep, we got it. This is really just a set I should be doing, but we're getting those. Aha, we're not getting this one, so we're not going -1, 1. It was me. The fool was I. I hadn't included one of my things in there. Again, as Rask said, I would build utility functions instead of reinventing the wheel every challenge. But I enjoy the wheel. It allows me to learn new things every time. Didn't learn anything here. Just learned that I type coordinates badly. Yes, we enjoy the wheel. But, boom, that's why we get tests. We can assert our things still work, and that's why we love tests when refactoring. Let us know exactly when we did the bad thing. So, we now have inlined the directions to a bunch of pre-calculated instead of calculated on the fly. This is so much better. Why is this better? Well, we traded time for memory a little bit, but that's a drop in the bucket. This is better because we can make what directions we go through customizable. We're going to do that right here. Directions. And this is just number. Yeah, of course, Rask. Have a good night. Catch you tomorrow. So yeah, now we make it where we iterate through the directions that we are passed. And then, of course, we need to pass it. So we'll pass all directions for solve 1, of course. TypeScript being TypeScript, don't you worry. Did that make the types happy? Okay, it did. No? It's because they're read-only things. Okay, we will make TypeScript happy. Boom. We just have to make it a little happier. Okay, so now it knows that these are arrays of tuples too long. Love you. So once we have all these, we're able to pass solve one. It's fine. It loves it. And now this is where we get to use part 2 a bit. We get to use this in part 2. So we get to say found MAS, found masses. We get to pass find words. And we look for MAS, not in all directions, of course. That's the wrong direction, in just the cardinal directions. And if we look here, we got a lot in there. So many that we don't want to look at with our eyes. But now if we get rid of that, we can see we have none, which is this. Where'd they go? Oh, well, I'm searching in cardinal directions, of course. That's not going to show them off. Diagonal directions, there we go. And now we have the 2 of them. 0, 0 with a direction of we're not going to show you, and 2, 0 with a direction of we're still not going to show you. Let's fix that. There we go. Now we can see the directions. So from 0, 0, we're going with the direction of 1, 1. If we go back to the drawing, is I don't have a drawing for this one. Let's make a drawing for this one really quickly. Over here. There we go. So 0, 0 in a direction of 1, 1. 1, 1. And then the other one it said was 2, 0. So here in a direction of -1, 1. So -1 means we go up, row, and 1 means goes right. So you connect them and they cross. Now, the reason we got the position and the direction is because that actually would allow us to calculate our middle coordinate. And if we just returned our middle, it'd be a little bit too prescriptive for my taste for this generic function, but here it's just the perfect mix of we're just giving you information, you do with it what you want. So now what we need to do is effectively do still this of tracking all the middles that have been crossed, but we calculate the middle using our row and direction and the length of the word. So let's do that now. Not there. And we'll do it there, and we'll drop this map. Did I drop it up there? I did. We'll drop the trim also, since that was just a paranoia trim. I think we'll... Yeah, we're going to drop all of this. So the power of get. If we need it, well, we can go back to get, or I can hold Control-Z for like 5 seconds. For const found of found mass and masses or MASs, we're going to const middle chord, which is found R plus found direction R times, and then this is the part where we do a little bit of math. So it's not times 3 because that'd throw me way off. It's not times 0 because that'd give me the m. It's times 1. So I'm just thinking through the math aloud before I get to write code for it. I mean, I know it's this, so I guess we'll start here and we'll iterate to greatness in a moment. Letter C. Boop, boop. It works. It does all of the things. Let's not do multiply by 1. Drop the world, turns out we don't even need that anymore. And we're going to rename this a little bit better to crossing masses, or mass crossings. There we go. It's a little better. Now we're doing, it's a little bit like this. I don't like the hard-codedness going on here. I don't like it a lot. Let's say word string. We'll set it to this. There we go. A little less hard-coded. Now let's do some early protections. If word.length modulo 2 equals 0, basically if it's even, we're gonna say that's illegal. Work on even length words. AC Films, glad to hear it. I am doing pretty okay. So now instead of ×1, we get to calculate middle index equals word.length minus 1. Alright, because word.length was 3, and this puts us at 2. Nope, that's not doing what we want. 3, 0, 1, 2. Let me look at middle index. 2, yep. Yeah, I think the equation I'm using here to get here is a bad. Oh no, it's just offset, right? Because we get to 0 by this. So it's -1, -1. 1 for the length, 1 for everything being 0 based. Gotcha. Middle index times middle index allows us to do that. We TypeScript this. Record string number makes that happier. And then we filter all the ones that have been seen twice. And I broke it. Oh, hey, I'm looking for the wrong word. That explains how I broke it. Okay, still working. Let me look at the NIS crossings. Yeah, 2s and 1s. Trying to think of a way to make that go away even better. So once we find one, we don't need to keep track of its count, just that we have found one. Let me say MAS middles. No, not too much new with me, C Films. Just still living life, you know. As you can see, I was able to get back to Advent Code this year. Anything crazy new with UC Films? Feels like it's been a long time, despite it being just a year or a little over, I suppose. So I have this, I want to say crossings found or let x count equals 0. So I think I'll do this one here, and this will be if we find, because this basically just is set, and if we've seen you before. So let's go even better. Middles equals new set string. There we go. So if mass middles, that's not how you do a set of strings. That's nice, C Films. Congrats. Definitely keeping you busy then. mass middles has middle coordinates. So I guess we will need to keep a second one. Counts. X misses. There we go. Sure. Use set string here. So basically be, thankfully we'll never find an X miss here. It'll just be if this one has found it and the other one hasn't. Calculate middle chord. Join on that. There we go. So if it has this and not X misses has middle chord, X misses add middle chord. Honestly, do I need to do this? Yes, I do need to do this. Middles add middle chord. Yeah, I really goofed this one up. Thankfully I can do this size. Nice. To my knowledge, C Films 100 devs is still going pretty well. Haven't had a lot of time to be involved, but still show up for some of the bigger things and still going pretty good, still going strong. So I've written this code and it just does not vibe with me. It works. If we have seen this crossed before and we haven't seen this, well, at that point, just go for that. Okay, so if we've seen it, we're basically doing a 2-count system, but instead of a hash map where we count from 1 to 2, we're using 2 sets, which I felt like would be better, but it just introduces a whole new thing with it. It needs a whole new variable name with a bunch of weird conditionals down here that doesn't make it clear what this is returning. So let's not do this grossness. Would recursion help my code? In this case, it wouldn't, because I'm not performing a problem that effectively is a subset of itself. A reduce. I could do a reduce over the entire thing here. It wouldn't help too much with readability, I'd say. I'm gonna get this back to a working state. Yeah, I can throw a reduce to it, see if it looks better. Oh, great, I'm putting all the symbols in here. Okay, and oh, it's not working. Up, double join. Don't double join. Boop. There we go. Okay, so we're back to going good. And yeah, we could. So let's inline that one. Yeah, we could go straight to a reduce for this. We'll see how readable that looks, to be honest. So return object at values of the thing. We'd still need the filter when we see how many 2s we have. This part actually would be reducible. So reduce, because we're doing a filter, then a dot length. We're creating an array and memory. We don't actually care about the array. We care about the length of the array. So this will be X misses. It's a really great name. And then count X misses plus count equals 2. We'll start at 0. Drop the length. Would help if my unary plus operator made it to the equation. Hey, why are you not being happy? So object values should give me the number. Yeah, lots of lots of the world still runs on Excel. C Films. That is not a surprise to me. Cannot be used on this in Boolean. Well, it would work if I put my unary plus operator over there. Boom. Yeah, but yeah, Excel can do a lot of powerful things. World keeps running on it. I'm sure you are now an Excel expert. So yeah, we used a reduce on that. Definitely made that work. Thanks for the reminder. If we want to go extreme though, you can see how a reduce would work on the entire thing. So it'd be calling a reduce on this. Reduce middles and then bound. Still be a multi-line just for my sanity. And this I would type as I did it there. Come here, you. Now, the only difference is that I changed it to middles. We return middles. Boom. So yeah, we can go super full reduce. Go over the array, and we were able to do this because we're effectively just having a single variable on the outside of this for loop. It was our accumulator, so easily convertible to a reduce, naming this as our accumulator and just doing our things to it and returning it for the next iteration to do their things to it. Personally prefer the readability of this, though this reduce will remain. And that honestly is functional as far. I really want to take this refactor. So with that, let me stage it and do one last walkthrough. So for solve one, we want to find all the words in the data string. Well, we want to find the words in the data that are Xmas. We want to look in all directions. So what we do is we keep an array of found words. I want to make this a generator. Yeah, this is a generator now. You'll still need the length, of course, so that is unfortunate for you. Actually, it's not unfortunate. What found equals 0 for cost of words. We still actually get the values, so but we don't build an array of it, so this is technically a little. It's a trim. There we go. Now for this one, you were already iterating over it. So yeah, I just like this because we were basically building an array of results to return, and we were returning them in bulk, versus here we are returning them as we find them, but you were using the yield, so we yield it to our caller. It does what it needs to do. When it needs the next one, this thing continues further. I like using generators where it's possible. They're neat. So back to it, we are going through this, so we modify this a little bit to like, hey, we just want to count how many of these you find. And we'll break it even further. Count generator results. Generator, I don't even know the thing for that. How do I type this? Can I just say generator? Yeah, I can do that. But boop. Count. I have never heard of a database called FileMaker C films. There are a lot out there though, so I would not be surprised. Does FileMaker do anything fancy or niche? That's usually the reason these Interesting databases spawn out. They're solving a very unique problem. There we go. So I just made a very amazing, super fancy utility function that counts how many things a generator returns. Never seen before. Hey, Lunar Request. How's it going? You're coming on back. Day 4, pretty good, honestly. The only goof I made was, a certain part. It was like, hey, look for X's. And I was looking for both pluses and X's. Once I figured that out, smooth sailing. Just on the refactoring stage now. Well, I was on the walkthrough stage, but then I was like, this could be a generator. So now I'm on the walkthrough stage. Part 2 easier than 1. Interesting. Yeah, honestly, I saw part 1 easier than 2 because you're just counting how many times you see it, where part 2 you're tracking another piece of state, crossings and stuff. But yeah, I can see how it could be a little bit simplified in a different way. Yeah, well, I mean, for part 1, all we're doing is just searching for words in a matrix. The only additional bit here is that you're searching diagonally, which, at least in the way I wrote it, is identical to searching horizontally or vertically. Uh, so you just looked for the letter A and then did some stuff based off of that. Oh, I guess that might be a smarter way of doing it. Huh. Yeah, I went all fancy of like, hey, look for an MAS and keep track of its middle coordinate, and look for another MAS and keep track of its middle coordinate. Did you see two of the same middle coordinates? You found a crossing. So I wrote it. I went so abstract with it. I overcomplicated it. I mean, yeah, that's at the end of the day. If it works, it works, right? So I think yeah, I definitely went over generic, which works for any letters that happen to not be MAS, but for this particular problem, yeah, I probably could have just looked for A's and then done a little bit more heuristics and been like, I found them. It's another reason I love Advent of Code. You always get to see all the different solutions. Yeah. Wouldn't have thought when you're all, tunnel visioned on what you saw the solution as. Sure. Gate 2K1, also easier. Okay, yeah. Looking forward to reading the Reddit and my friends' solutions to these. It's like I got real fancy. But I like my fancy. I'm so proud of it. So, let me see. Yeah, so for all of them, we have use on the base find words generator. It looks through the things, it finds the words, it skips if the first character isn't the correction, and then looks in all directions. In this case, for part 1, it was physically all directions. This could be broken into a function. There we go. Let's do that further. Word exist at, so it's world string, and then R number, C number, RO number, CO number. Just shove this into here. Looking for this word. I'm doing it right now. Dang, did some of the leaderboards solve it an under 5? I've really been looking at it. Where are the times? Oh, under 5 minutes. Yeah, I thought you were saying 5 seconds. I was like, that's crazy. So I mean, I do know there's a lot of utility like super users who like have a lot of this defined as utilities. So like they see a grid, they have a dot grid, they see a thing, they got some fancy dot searches and stuff. I do also know there, at least this year, there've been a few AI usages. I believe one person apologized they didn't know. Advent of Code doesn't want AI users targeting the top leaderboards, but they're all obviously not using AI here. Yeah, it's a skill. There are a fair number of them who actually record their solutions and yeah, just being perfect. No goofs, no imperfections, just well-oiled machines they are. It's impressive. Yeah, see filmed I'm trimming down some loops here. I mean this function's gonna simplify it a bit. Um we do need to iterate over things. Iteration's kind of an important part. Even going functional, we're still gonna get loops here. I'll see what I can do. Maps are still for loops. C films, they're just different flavor. They're the functional for loops that have are functional that don't count. Let me finish this function because this will make it shorter. Const word found equals word exists at world word rcroco. This is a string array, not a string array. There we go. Okay, so boom, that does make it shorter. No, I don't like the lack of curlies. Let's see if I can. If there's any more I can squeeze from this. Gotta go through the rows, gotta go through the columns, gotta go through our directions. Word exists. Yeah, this is a good order of them. Um, Directions that pass this yield this. That doesn't get any cleaner. It's just a helper to count the size of a generator. Gotta iterate over these. Yeah, we don't get any less for loops out of this C films. But we did get that part clean, so appreciate. Okay, now maybe I'm done refactoring. Yeah, C films, to get it even shorter, we go one character variables and functions, but we've already hit the readability limit, I'd say, using RO and CO, find words, CI. Oh, maybe we don't need. Now we can go for index here. No column, yeah. We're hitting the readability limits of short code, unfortunately. Okay, maybe I'm done refactoring. We'll see once we go through it all one more time. So we find all of the Xmas words in data going in all directions. So we look at every coordinate. If it doesn't start with the beginning of the word, then no point in looking in any of the directions. If it does, go through all the directions, the row and column offsets, and check if the word exists at that position. This little helper function goes through all of the characters. You don't need to look at the 0th character because we're already looking at the 0th character in this check here, so we can slice 1 to skip the 0th character and then go through all of the inch. That breaks it, doesn't it? Yeah, it does, because our I is now offset by 1. But we can fix that by doing the offset over here. No, we can't. Oh no. It's because that needs to be put in there. There we go. It's the for one less iteration, we got to go there. Anything, I'd rather slice on the entries, but this is good enough. So yeah, we go through all the characters of the word. Not the first one though. We get the new row and the new column by calculating the row plus the row offset times this. I'll put this in more parentheses to make it look good. There we go, much more readable. We check if that place in the world isn't the character. If it isn't, either because it's a wrong character or we've entered the undefined lands, then we return false. If that isn't the case, we return true. And then we yield the, if that word is found at that location, the row and the column of that word, and the direction it was found in. And then for this one, we just count how many were found. This little count generator result helper. But in solve 2, we do the very similar thing. First, we made it a little bit customizable that we're looking for any word, but it has to be an odd length. So if it's divisible by 2, we can't help you there. Then we get the middle index of the word. So that depends on the length, but length -1 because we're to 0 offset, not 1 offset, which gives us, in the case of MAS, 1, gives us the index of the A, which is the generic way, an abstract way of doing it versus a more efficient way, but I like this way. We then keep track of all the middles, which are renamed to middles, and we go through every found word, which I'm going to destructure our direction like so. So we get the row and the column of the found word and the direction. The trick is that we are only looking in the diagonals, so we do not find the pluses. Well, we're looking at any horizontals, only diagonals. Then we calculate the middle coordinate based on the middle index. So it's the exact same calculation we did for finding each character of the word, but down here. We take that middle coordinate, we squish it together just to give us a single key that we can use in our hash map for saying, hey, add 1 to the number of times we've seen this. You haven't seen this? Well, you've seen it 0 times, so still add 1 to 0 to get us to 1. Finally, that gives us a hash map of all the middles we've seen and how many times we've seen those middles. And we add up all the times that we have seen 2 things crossing, or 2 the exact middles, which can only happen at a maximum of 2 because we're not considering pluses. And that is how it works. As I was going through this, I did see another opportunity for factoring. I was like, I'm not going to do it. But then I was like, okay, I'm going to do it. This is effectively an every check. We're checking that everything equals this character. So I'm going to see if I can rewrite this as an every. So it's not all directions, word that slice 1 dot every, and then it's character and index. It's all of them equal the character. I'll have to calculate new row and new character, but let me do that here. Boop. Gotta put the optional chaining there to protect us from the undefined lands. Boom. That is exactly what it was the entire time. So I was able to get rid of, at least in syntax, one more for loop. Still looping, of course, but not with the syntax. So yeah, this is relatively readability. I say is a little the same, maybe slightly less, but if anything, slightly more because it's not a return false or return true. We use the dot every, so we're checking that every character in the world equals the character I'm looking for. So I love it. And yeah, honestly, that is how my solution works over Advent of Code Day 4's challenge. As others have discussed, there's a fancy way where you just look for the number of A letters and do maybe a little heuristic of do I have characters in all four directions and call it done. For this particular problem, which would solve it, but I went a little more generic or abstract and solved for any crossing of characters or words that you want to look for. So this works on MAS, but it will also work on any other one, which I am happy to say. With that, that is as far as I am going to optimize it. And yeah, it has been a pleasure as always. I will come back for tomorrow, but until then, have a good time. Bye.